All right, we're back. All right, from the first day we had this. I hope everybody remembers this. This is two. This is number two. We have this. We want to do a little bit more about this before we leave the subject. This shouldn't be very long. Maybe it is long, but anyway, this what we have been doing and what we're doing hopefully is something that everybody knows, because we assume people know something about algebra. They know x squared plus y squared equal to 1. That's a circle. Because Pythagorean is done in 8th grade, I believe.
But we don't learn conic sections in 8th grade.
There's no conic section in here. Just x squared plus y squared.
A circle's part of conic section.
Yeah, but so the thing is, if you know Pythagorean is by the way, for those who doesn't know, that probably don't belong here. Anyway, sorry, this is x, this is y, this is r. If you have this, x squared plus y squared equals r squared. Why it is so, that's not today's topic, but when you have x plus y squared, x squared plus y squared constantly equal to r squared, and what you're gonna have happen is this thing is gonna go around. When this thing go around, that forms a circle. Every point on the circle that satisfies this equation. You know? So x squared plus y squared equal to r squared or whatever. That's a circle. What about x squared plus y squared equal to I? Have any idea?
No.
Okay, never mind. Food for thought. By the way, this is yours. Okay, now we want to do a little bit of something about this, about these operations, right? That this is probably insertion. Get rid of that. We know that. Okay, well, I just gonna write this out. I want to break this open. How do you break this open? Okay, never mind. Okay, okay, you said never mind, right? There's a cheat. There's a whatever. There's a shortcut. This is really cheating. Cheating way is you treat this. I mean, this is join. What is it called?
Union.
Union. Yeah, you treat union as a plus because of the union, right? You treat join as a multiply.
It's called an. You said it's an intersection before.
Intersection. Get that paper. What did I call it? I don't know. The thing is, these words, once you know, this is a good and bad things about math. Okay. Yeah. Intersection. Okay. What did I just say? A joint?
You said joint.
I probably call it a joint if I say it's a joint. Because you see the thing? It doesn't cross my mind, all these words. But it gets into my mind, but I never.
Stop with the excuses. Let's keep going.
No. I'm just saying.
You're getting distracted.
I have a point about math. Once you have these symbols, right? Whatever you call it doesn't really matter. Okay. You treat in this is the intersection. This is union, right? You treat union as a plus. You treat intersection as a multiplying. So this equals to a multiply b plus a multiplying c. Yeah. And this one you probably can get. What about this? Let me see what I'm doing first. I'm gonna do this in an orderly fashion. I want to break this knot. How do you break that?
Wait, what?
This is A union B, right?
Oh, what's that line?
The line is a knot. Anything A union B is a whole bunch of elements, right?
Yeah.
This is all the elements that's not A union B. The line is not. I want to break this knot to not A, not B. In other words, let me do this. This, you know, as we know, all the algebraic things get into a graphic, right? Right. This is A and B.
Yeah.
A, B. That thing shows there is anything that's not. Is this shaded area?
Yeah.
Not this. Not this. Not this. So I don't want to say A union B not. I want to say A not and B not. How do you open this up?
Can't you just say A naught and B naught? Like,
Okay. Yeah. A not, B not, what?
can you do like this
Mhm.
and this?
What's the relationship between the two? Multiplying? I mean, intersecting? Union?
Sure.
No. Look at this. No. Just, no. Okay, yeah. Assume it's union. See what happens. Not A union, not B. What is that?
Wait, it's not a union.
Not a union, right?
Uh,
So what is it? Is that a guess or you figured that out?
I figured it out
How do you figure that one out?
because if it's not A,
Mhm.
then it's pretty much B too. So if it's union, then you're just saying it's everything but this, where you're just saying
Yeah.
everything but this and everything but this. I guess. Like,
Right. Do you see it?
Nope.
You didn't see it. Okay. Let me do this graphic way. Not A, right? Not A. This is, let's say this is A, right? Not A is this part. This is A, right? This is not A.
Okay.
Not B is this part. Not B, right? See that?
Yep. I see.
So not A. Oh, ignore this part that protruded. Not A join not B becomes only this part. Not.
Mhm.
Oh no. What am I talking about? Not A is. Well, anyway. Not A join not B. It means it both in not A and both in not B. Right. So you're just counting the cross areas. Cross areas is both not A and not B, right?
Yeah.
So the cross area comes to all this area except this and this and this, right?
Mhm.
Yeah. So that's what it is.
Okay.
Okay. I think I was wrong. What I said, but it was convoluted logics anyway. Okay. Now let's do the other one. Do the other one. What's this?
I don't know. The other way around.
it's
Yeah.
everything but this small thing. Whatever.
Yeah, it is. Actually, right, everything but, yeah. But when you write it in not A and not B, how do you write it?
Same thing, but you switch the side.
Wow.
Are you guessing or you... Yeah, it is. Not A, not B is anything but this area, right?
Yeah.
Okay, not A is not A.
Mhm.
Not B is not B. We still have it, right? It's not A join not B. That means anywhere that has anything.
Okay.
Not A join not B. That means anything except this, because this is the only place there's nothing.
Okay.
Not A join not B. That's
Yeah,
either not A.
yeah,
Then
okay, I understand.
Okay. Okay. Now, let's do some things. Huh? Yes, A join B. A intersect B equals to A. Let's say this. A. Okay.
Yeah.
What's
What's
let's
this
just say
line?
this is we just did on the. Can you get page 1? Oh yeah, this is the whatever. That's
Yeah,
called an equal.
no,
to
I mean the line. Where's the line? Like, what's the line? of
line
the
is
subset?
could be equal to. This is a subset. Has to be a subset. Cannot be the same. The line make it could be the same or the subset.
Okay.
Oh, okay. I'll just hold on to this shit paper. I'm going to use it later. Okay. From this, can you get to this? If A join B is actually A, can you get to this?
Yeah.
Okay. Did you actually see it or what?
Because A joint B equals to A is just a circle, like for this circle overlapping another circle.
Yeah, right. If this is the A, let's say this is A, right?
Yeah. And then
Probably.
B is
Yeah.
also that too.
A join B is this,
Uh-huh.
right? So B has to be bigger than this. So B join A has still A. In other words, let me just draw another circle. This is B. This is A. B join A is A. Then A has to be inside the B. Every A has to be in B. Otherwise, the joint will take some of the A part out of it. It wouldn't be A anymore.
Wait. No, I was saying like this. And then,
Yes, you mean the same, right?
yeah.
Same is okay.
Is it just the same?
It's the same, then joins the A. Yeah, if it's the same, then it's the same. You mean A join A, right? That's always true.
Yeah, but I mean A. If it isn't A intersect B, if it equals to A, shouldn't B equals to A?
Okay, I didn't catch that. Say that again.
If like this is true, then shouldn't B equals to A?
Shouldn't what be equal to A?
Shouldn't like
B
B equal to A, like the circle be equal to A?
Oh, this is only asking to join. This is only asking for those elements that's in A and in B. This is the A join B is a set, right? The elements has to be in A and in B.
Yeah,
Not
but
necessarily both.
But like the
In other words, look at this element. This element is in B, right?
yeah.
Right? It's not in A. So when you do A join B, this thing get taken out. When you do the joint, it has to be in both A and B, right? So this part is not in this joint, not in this set.
Okay.
And this set, A join B or A intersect B. A intersect B
Yeah.
is A. It doesn't mean B equals to
Wait, so does the A intersect B mean it includes A, or does it mean it like the sides of the circle equals to A?
A. Yeah. Ask that question again, looking at this picture.
So like when you have hold on. Wait. Actually, never mind. I got it.
Did you get it?
I think.
Okay. All right. It also goes back, obviously, right? This says A is inside the B in picture. Wait, if A is inside B, obviously you join, then you take out anything that's not in A, right? So this it goes back too, right? From this, likewise, you can get to okay.
Okay.
You just flip this. Oh, okay. We're gonna just draw the other way. Oh, I'm smart. I draw the big one first. This is A. This is B, right? This is obviously the B is less than A, right?
Yeah.
Or equal. Equal. When you equal, B is A, so it doesn't matter.
Oh,
That doesn't matter. This is B is less than A, right? This is for that to be true. And now A or B.
Equals.
A or B, either one of them is A, then A is the big one. The B has to be inside A. In other words, if B is something like this, right? then B is going to introduce something into it, into new things into it. It wouldn't equal to A. It would equal to A and something, right? A union this section. It would be A, A union this section, right? Okay, now let's do another one. I'm not gonna do it actually. I don't know. There's a whole lot of point doing this. Okay, well this goes to what? This equals to what? What did I just do? Can I have that sheet just for a second? I'm sort of lost what I'm doing. Oh yeah. Okay. For this part of it, just a note, an extra note on this part. Okay. This is kind of this is something else. I want to go back to this. When you do three, what does it come to?
Comes to 3 things.
Yeah, it's 3, okay? S1 not, S2 not, S3 not, okay? And then the other one, this is all the same. And the same logic, same everything, just put more into it. Okay?
Okay.
Alright, now this is the equal, so it doesn't matter which way, okay? I'm gonna do a algebraic way of proving it. Okay? S1 union S2 S3. Okay? We just look at these two. Look at these two. Okay? This can be written as S1 S2 union, right?
Yeah.
This is okay?
Yeah.
Yeah? Sort of this is in the bracket, right?
Yeah.
Now, I'm treating this in the bracket as one thing, and this as one thing. And you use that rule, use that 2-element rule again. We're using this rule again, okay? So now this equals to, in other words, S1 union X2 and S3, right? That's S1 union S2, this together, right? Is going to be union S3, right? And for union, just one in either. It doesn't have any orders or anything, right? It's just you're in any of them, you're in anyway. So the bracket can break out. Huh? This is this. Oh, I did the second one, but then anyway, you can do the first one. It's the same thing. If you do the first, I meant to prove this one, but I wrote that down at this one. If you do this one, just reverse everything. All the signs reverse. It'll work, right? All right, now let's see. See if I want to do this or not. Yeah, okay. I do actually want to say this. When we say union, right? When we say a union, like I don't mean union. I mean any set like an A and a B, right?
Yeah.
You can say it's a king and a man, kind of situation. This is the man, this is the king, right? This is the man, this is the king. Of course, this is the outside is the woman. Yeah, man and king or whatever. Think of it. This is almost like a solving a problem thing, just an insertion of this. Think it as a conclusion, of a fact.
Yeah.
Say John is the king, right? You mean John is the element in here. The element is, of course, the element is king, but you can also treat it as the element is John is a king. Do you get what I'm saying? a true a true statement. John is a king here. Okay, here's John is a man, not a king.
Yeah.
Yeah, here John is a woman. Well, anyway,
John.
name a woman. Just say whatever, right? A person, right? Here's the person is a woman. Here's the person is the man. Here's the person is the king. Yeah, that is true or false thing. Yeah.
Yeah.
That should be enough. And then that goes to sufficient and necessary. Because sometimes you think this is a king, this is the man, this is the woman, and this is the all people. You don't think this is as a logical matter, as true or false thing. Is a certain thing here is true, certain thing here is true, certain thing here is true. Yeah, actually, when you put in this is king, this is man, this is women, you are saying these element being a man is true. This element being a king is not true.
Yeah.
This element being king is true. Being man is true. Being woman is not true. Being a person, which is the whole area, is true. See it that way. So, in other words, this sufficient and necessary, you can just treat it this way.
Okay.
Okay. Does it make any sense what I just said?
Yeah.
Yeah.
It does. Okay, good. All right. Now, that is to how to look at this stuff, right?
Okay.
And this is we now we do an example that I think we just do an example then we're done. We do an example. There's probably a little bit of number in it, but anyway, we're looking at this example. This is A. This is B, right? We're looking for probability of this stuff. Okay. There's a probability of A. There's a probability of B. This is the probability for A to happen, probability for B to happen. If you flip a coin, what's the probability of head?
Half.
Yeah, 50% or 0.5, right? Then there's a P, there's A. This means both happen. I mean, this means either one happen. This means both have to happen. There is a I probably just don't want to do this. Let me just not do any of this. Let me just do one thing, then we're done. Make it very, very easy. There is a thing, like if A already happened,
Yeah.
what's the chance for B to happen?
Which
You're looking at this area. If you know A already happened, what's the chance for B to happen? Right?
a lot less.
Yeah. You write it as, you write it this way. If A already happened, for B to happen. Yeah. This probability. Okay. How do I do this? Let's just do it this way. Because I really don't want to get too much into this. For either to happen equals to A to happen, B to happen. This is okay.
Yeah.
For A and B to happen, right? But I mean either A or B to happen, right? It's probably the A to happen and probably the B to happen. Is it okay?
Yeah.
You sure? What about this shaded area? You count it twice, right?
Yeah.
For A to happen, you count this area once, right?
Yeah.
B to happen, you count out again. So this probability is this is more than this, because you count the same events twice,
Yeah.
right? So you multiply this. I mean, you minus, you take this part out, because this count this area twice, right? So you take one out.
Yeah.
That equals. Yeah. let's look at this. It's if B happens, if A already happened, B happened, right? A already happened. That's A already happened. That's A, right? A happened,
Yeah.
right? And B happened is just that's just that shape, right?
Yeah.
This that means the A and B both happen,
Okay.
right? That means A, B both happen anyway. But this is the chance for A already happened. So in other words, when A happened, B happened equals to this. Does that make sense?
Wait.
Does that make sense? Let's just do some kind of example. Let's say you flip a coin. This is the head, and this is the tail, right?
Yeah.
Then you flip it again. Okay, let's see. Okay, this is all right. You flip a coin.
Yeah.
Yeah. This way is tail. That's head.
Yeah.
Right. You flip again. You flip again. Right. And this is the second time. This is the head. This is the tail.
Yeah.
Right. So now you want to know if the first time is head, then the next time. How about the next time is head? I mean, the first time is head. What's the chance for next time is head?
Oh.
Right.
Yeah.
For both to come out head, that's 1/4. Right. For the first time to come out head, that's 1/2. Remember? Yeah. This is the first flip, right?
Yeah.
This is the first flip. This is 1/2.
Yeah.
Right. For both time to come out head, that's 1/4.
Yeah.
So this is 1/4. This is 1/2. And you know this is 1/2, right? If the first time come out head, the next time you just do the next time, right? So this is half.
Okay.
That makes sense?
Not really.
Okay. Let's do it this way. If A happens, what's the chance for B to happen? Okay. I think I just let's push this one. I actually try to push this one. Where's your problem? These three probabilities you don't have problems, right? It's just the relation you have a problem, right?
What? Wait.
Oh, let's do it this way. Let's just say the chance for anything to happen is proportional to the area. The bigger area, the more chance it will happen. Okay? So the probability is the area. You measure the area is the probability. That's fair, right? It's just, something that happened equally. Yeah, in this area, right?
Okay.
So the probability is the area.
Okay.
That makes sense, right? That makes sense? Bigger the area, the bigger the probability. Yeah. Just say you have people standing in there in the uniform, equal distance, and a whole bunch of people. So the area is proportional to, or the area is equal to the people.
Or it's like lottery. More lottery tickets you buy, the bigger the probability you'll win.
Yeah. Yeah, actually, if you buy more, you want to buy all different numbers. And then, yeah, true. That's true. Yeah. But this is a uniform. Lottery ticket, how do you say lottery ticket is a uniform? But in any case, you understand what I'm saying, right? Okay, now, the probability for, if A already happened, the probability for B to happen, right, is the area of this called the area of let's just write it out. Right, this is for probability to A to happen.
Yeah.
Okay, right? This is A happen and then B happen as well.
Yeah.
Both of them happen, right? So now, let's look at the probability that the first A happen and then B happen.
Okay.
How do you do that?
First A happens, and then
For that means A happen and then B happen. That means the proportion of area in here, that's also B.
yeah.
It's B divided by all the A's. In other words, A already happened, right? Now you're one of these people. You're in this A area. Now you pick one people. What's the chance to you pick a B? That's area of A divided by that's area of A join B divided by area of A, right? This shaded area divided by the whole A area.
Oh, yeah.
Right?
Okay, yeah, got it.
Did you get it?
I understand.
Okay, then that's what they're saying basically. Now your proportional doesn't really matter. If not proportional, not proportional. If you have more things in the dark, then the more things everywhere. I mean, up and down also doesn't matter. You know. The other stuff. I don't want to do it now. The plan here is we avoid all numbers. Now we deal with numbers next summer. We're gonna do this in 2 summers, just to make it easy for you guys. And that is all for today. And this is 5, right?
Yeah.
2 to 5 is it can be treated as a unit, and then we're gonna go to 6. That'll be a different area. Actually, it will be geometry. We move quickly from one area to another. We cover the whole thing, assuming you know nothing. As you can see, we start from 2 apples plus 3 apples, and we're gonna cover this whole thing as fast as possible. Then we'll get into physics, because without the preparation of this, then the physics doesn't work. And anything that's numbers, that means if numbers, includes a combination. In other words, if you have a bag, not doing this paper, that is if you have a bag of with 3 white balls and 5 black balls, and you pick 3, and what's the chance for you to get say 2 white balls? That kind of thing. Number, that means in let's say in 250 days. Today is a Monday. 250 days is what day? 200. Did I say 250? 250 days. What is the 250 day?
That's 250. Hold up, I can actually do this. 42. It'd be today's a what day?
Today is Sunday.
Sunday. It would be a Friday.
Okay, how do you get that?
I just take as many like I did 7 times 30, and then took out 210, and then I did that's 40 left, and then I did 6. I'm like doing it by weeks, so 7 times 6 is 42, and then yeah, that's the amount of that's the amount of
7 times
6 is 42.
Oh, okay.
And then you just minus 2, and then just minus 2 from the day you're right now.
I didn't explain it.
Like,
how do you get it?
So I'm like, 7 days from now will be the same day, right? So,
yeah, of course, yeah.
So for 250, I'm trying to take as many 7s out as possible.
Good. Okay.
So I take 30 times 7 out, so then there's 40.
Oh, okay.
And then I do 7 times 6, and then there's 42. And to make it 40, you take 2 days.
You're back 2 days.
Back 2 days, yeah.
Okay,
And
okay,
then
yeah. That's the idea.
Friday.
We don't care about you divide essentially 250 you divide by 7, right? You don't care about what the sort of the whole part is. You want to know what's left over.
Yeah.
There's whole series of this, and then for instance, when you have x plus y equals to whatever equals to 4, right? You know there are infinite number of answers, right? And it's continuous, whatever, right? Now I'm telling you, x and y are both
Positive.
No. Both integers.
Oh.
X and y are both integers.
Oh, that doesn't really.
What's the solution? You can get the solution now. 1 and 3 is 1, right?
Well, there's still an infinite amount
Infinite
of
amount,
solutions,
right.
So, yeah.
Yeah. That's just the start. I can give you another equation or something else to limit it. But all of those kind of things that deal with numbers, whole numbers, what's prime numbers? How many prime numbers under 100?
Like,
Is 97 a prime number?
yeah.
Maybe it is. I don't know.
Yeah, I'm
probably
pretty
is.
sure it is, yeah.
Those issues, we're gonna deal with that next year. It doesn't bother anybody, anything. Also, statistics. We'll deal with it next year. Okay. It doesn't bother any of the things you do because you do the basic probability, right? You flip a coin and stuff, but more complex things. There are 100 people. What's the probability of say girls? Your 100 student. What's the probability of girls?
I don't know, 50%.
Yeah, maybe a little more than 50 because the birth rate girls is a little higher than boys, naturally. In China, the rate is 120 to 100, but in boy, because they, whatever. Those things, right? When I tell you when I tell you about this, you understand what I'm saying, right? So you're conversational. People can, you can deal with everything, but everything except anything that's math, like a contest, like AMC type of things. It doesn't cover that. Okay. So next year we're gonna cover that. This year, we're not gonna do it, and that's bye.